So we had derived this general expression for the moment of inertia about any axis. Which we wrote like this. So these are our normal vectors for the particular axis, which we can write in terms of the direction cosines, the inertia tensor, and then the same normal vector in row form. And this gives us a particular number for that moment for rotations about this axis n. Now what we want to do is to find a way to work out the inertia tensor for any particular basis transformation. So we want to look at a change of basis. So this could just be a rotation. And we can ask what to do to transform our inertia tensor. So we've already gone through a lot of work to derive this thing, and you don't want to derive for any particular small change in a basis. So there's a simple procedure to do that, and to see how that works, let's recall that we had earlier came up with this expression where P was our transition matrix. For the basis change. So you look back over in the previous notes that we made, especially on the section where we were talking about tensors in general, and we had this transition matrix. So this is for any basis change. We had explicitly written it for a rotation, but this could be for any particular basis change. And we have this relation where we have W, or omega, sorry, in the original basis and omega prime in the new basis. So we have this expression for how the angular velocity vector would change under the change of basis. We can also do the same expression for the angular momentum vector. And now we can substitute in, because we know that L is I omega. And now we can just make a substitution for L. So this is P L prime, and we have our tensor, and then we make the substitution for omega, P omega prime. And then we want to isolate for L prime. So we multiply by the inverse of the P matrix, our inertia tensor, P omega prime. And we can compare these expressions. So L prime has to be I prime omega prime, and then we can instantly write down that the new inertia tensor has to be P inverse our original inertia tensor times p. So this is just basic linear algebra. But again, it emphasizes the point of view that this inertia tensor acts like a transformation. So in the language of your linear algebra, this is just a transformation matrix. So in order to do these basis changes, you wouldn't have to know anything about the physics of what these quantities mean. You could close your eyes and just calculate based on your linear algebra. But this gives us the expression for how to transform our original inertia tensor into the inertia tensor represented in the new basis.